Hello, welcome to this week's Retrieval Market Demo Day. Today's date is Wednesday, the 2nd of March, 2022. On the schedule today, we have Myel giving an update on, Rust, WASM data transfers, and then Ken Labs giving an update on Pando. So if anyone's got any questions, please put them in the Slack channel as usual, and over to you, Thomas.
Cool, thanks. I'll just get right into it. All right, so you should see a browser if all is well. Cool, so yeah, we've made a few different changes to our architecture since the last demo probably. So this is kind of the first kind of version of our a new implementation, which is kind of built in Rust and compiled to WASM. So we're kind of, moved away from our JavaScript client implementation because of performance bottlenecks that we just couldn't overcome. And so we've kind of been re-implementing everything with a single code base in Rust. So now our POP is in Rust too, and the client is compiled to WebAssembly. And so this is kind of a very simple demo, which is basically just makes a request, and you can see loads of a GIF. And essentially, we used to run things in a service worker, and so we kind of had a few issues with that with WASM. So now we're kind of running this in dedicated workers. So the WASM client, the whole retrieval is happening in a background thread which is sharing memory with the main thread. And that way we can stream the content directly from the dedicated worker to the browser. And the API is very simple, still the same as a fetch request. So you get a promise with a response, and then you have a stream, and you can use that to just, attach to any kind of HTML element or stream or video streaming or anything like that. And we're still working on the video streaming loader to be able to stream with HLS and things like that. So we'll have a more comprehensive video streaming example demo soon. But so right now, this is just basically doing very simple content like images and things like that. And the performance we've seen so far is we've doubled the performance than what our JavaScript client used to be. And that's without any optimization. So we've kind of been working to complete all the features and make this very usable so that we can get online as quickly as possible and run those POP nodes and have kind of measurements running on a live network. I can do different files to for the demo if you want, just as an example. Let's see, I'm just gonna to load different things. So here we just have regular CIDs for images. We're still working on the pathing since it's working with UnixFS DAGs. And so we're implementing the reification right now to be able to have path that maps to selectors, so we can select specific entries inside of a UnixFS directories. Before that, we used to do multiple transfers. So we would do a first transfer that we retrieve the entries and then do another transfer. But since it's gone out in Go, we're implementing the same thing in Rust so that we can do the same thing. And it's also the implementation is fully compatible currently with the Go implementation and the latest Go graph sync and Go data transfers. So this is, this also implements the data transfer protocol, which enables us to enable payments. We still don't have payments running just yet, but we have all the things together. So we're really focusing on optimizing performance on the transfers first, and then we'll add the payments to it once it's working and nicely and usable. But we should be fairly quickly since we've already have the experience of implementing this in Go and in JavaScript. So yeah, this is kind of everything. I guess I could go deeper into some technical details if anyone wants, or
yeah, if possible, that'd be great. I mean, it'd be nice to understand sort of, yeah, what the sequence flow is from the browser here through, as you said, it's now a web worker, is it, rather than a service worker?
Yeah.
And then to Myel pop, just to go, yeah, behind the curtain.
Yeah, definitely. Well, so the entry point is still WebAssembly. So basically, when to load the API, to load the interface to make the requests, you still need to load a WebAssembly file into your HTML or your JavaScript. And so once you have that, you just initialize the WebAssembly bundle, and then you can call the request method with just a simple IPFS path. So you would have the root CID in there, and then any kind of arbitrary path that you need to reach for the file with the file name there. And so essentially that method in WebAssembly will spin up from WebAssembly a new worker, and then call that a method in that worker. So WebAssembly is sharing memory with the worker. So you have like direct memory transfer. You're not copying data or anything like that. And so essentially that the retrieval starts from within the background, the web worker that was spun up during that request. And then as it streams, it's progressively validating the blocks and sends back the blocks as shared memory back to the main thread, which is then basically transformed as a readable stream into JavaScript. So then JavaScript has like a basic HTTP response that you can consume as a blob, or you can stream or do anything kind of operations on a byte stream. And so this is kind of consumed from JavaScript while the background worker works, and is basically validating the blocks and then sending them progressively. And then when it's done, the stream is closed, and essentially the blob is complete. So you can use the data to do whatever you want. And then the worker basically still running in the background, so you can send other requests to it and things like that. We are exploring ways that we can spin up child workers as well. So we could have multi-threaded operations. Essentially, we could parallelize some work and go even faster. So that would be a good way to improve performance, which is something that was not possible previously inside of service workers, because you can't spin up workers from a service worker, but you can from different workers. So this enables ways that we can almost get to the same kind of multi-threaded environment as native Rust would have, or Go and things like that.
So is the main reason to switch from service worker to a web worker because of that multi-threaded aspect? And what is anything that you're losing by making that transition?
So actually the main reason was that we couldn't cleanly load WASM inside of the service worker, because essentially you need to register the handlers immediately when you initialize the service worker, but there's still a little asynchronous load time during which you need to load the WASM. So essentially you need to do a little bit of a hack around, like adding a promise to the global scope and then waiting for that to resolve in the handler and things like that. So it was just kind of it was a little messy and complicated. So that was kind of the first thing that made us explore different things. And then the multi-threaded aspect is also something that we're excited about. So I think both of these things. And also, you still have the cold start issue, which, when you have to register a service worker, there's still like the installation phase that can add a little time. So these things are definitely things that we're considering to improve the initial load speed. But the thing that you give up on the other side is that you can't really have a very clean HTML only API where like the requests are directly proxied. You still need to use that WebAssembly API. So essentially you would need to create abstractions, like, I don't know, some types of React components or whatever you're using as a framework. in order to work really smoothly and then load, web components that load images and things like that. I think that it definitely adds a little overhead, but we're definitely exploring solutions to make this simpler. So yeah.
Awesome. Yeah. Any questions? I suppose we haven't got too much on the agenda today, so we can probably take questions in between the talks. No. Okay, cool. Well, in which case, over to you, William, for update on Pando.
Thanks, Patrick. I'm in the car at the moment. Sorry,
no worries.
I was just aware it's the time now. So yeah, I just stopped the video and share my screen. Okay, hope you guys can see my screen now.
Yep.
Okay, today I'm going to give you some update of the Pando service. In past 2 weeks, we have been focusing on the Dealbot integration, and the Dealbot has completed their integration with GoLex and data publish. So according to the integration test, we realized some issues. So we updated the metadata specification. I will talk about shortly. Then I'll say that we have completed the Dealbot integration. We can see the connection established and the message exchange. Now we are waiting for the first batch of metadata published by Dealbot. At the same time, we are still addressing some issues. So in next few weeks, we will be still working on integration test, I'll say. The last thing is a consumer example released in the GitHub repo. So any consumer interested can go and check out the example by utilizing the Pando SDK. So how you can sync some data from the Pando service. So first of all, I want to show you the change in our doc. The main thing is Pando accepts IPLD data from the metadata providers. We updated we can see specification or protocol. Now, these three are the required IPLD nodes, provider, signature, and payload. So provider is a provider's peer ID. Payload is where you should fill your metadata. It's a bytes of your serialized metadata. And in terms of signature, so this is how you should sign your data. So the bytes of previous ID, bytes of the payload, and the provider. So get them all concatenated and assigned. So this is signature you should provide to Pando service. At the Pando side, this is also the mechanism we use to verify. The last thing is it's not changed, just to emphasize the previous ID. This is the node you should use to link your metadata if you're a provider. In this way, Pando service is able to sync or do a recursive sync for your data, even some of or the notification between are lost. So this is a guarantee for a full sync of your metadata. As the last thing I want to show you is a consumer example. So this is we recently developed. So it's pretty simple. The idea that you go and fetch the head of a provider from Pando service over a HTTP API. So you learn the head and use it to do a sync. So it's pretty simple, so that you can fetch the data you are interested. Before that, you should sync with the provider, so you are aware of the data format or the schema of the provider metadata as it's been serialized to bytes and stored in Pando service for now. And now I'm going to give you a quick demo here. So we have two examples, provider and the consumer. So if we simply run this provider, so it actually, what it has done is with this peer ID, this example has sent so 2 nodes to the Pando service, which is running in our host in production. I just shut down the provider, and these 2 strings are the CID. So in principle, it has already been stored in Pando service. Now I can use a consumer to fetch the data just provided. So I'll say that, so you can see this is mostly just the log information for data transfer and the graph sync. So if we scroll down to the very last 2 lines, so this is CID of this is the latter one. If you see here, this one. So this is the head, and it's going to fetch. It has fetched all the data from the Pando service, get the sync down. So we can see the sync succeeded here. So it's a very simple example. Mostly this is for development purpose. So any provider or consumer can go to the GitHub, check out the examples of consumer and provider, see how to connect to our Pando service. If you are interested in running locally, you can also follow the documentation here to build your own Pando service and the client and get it started in your local dev environment. Okay, so this is a Pando service in production now, and not too much information from the dashboard. So there's only one provider registered, which is their bot, and I think the master instance or the main instance. So we are still waiting for the data published. Okay, I think that's it for Pando. Thanks.
Great, thanks. Yeah, any questions on Pando?
I had a question just to clarify. In the metadata spec, is the previous ID the CID of the previous entry, or where? I'm not sure I understood well where it came from.
Okay, technically, or from development or engineering point of view, we are using the link system. So essentially, it's also a CID, but you need to use a link system to produce or create a link, so that the link can be used as the previous ID. So this is how you can build it. So I see if I can show you the code here. It's not linked. Yeah, this is what I'm talking about. So this is a link system. So if you use a link system, you can build your link for the previous ID and get it stored, so that next time when you produce your new data and want to link back to the previous one, you can use it. Yeah.
Gotcha.
Cool. Yeah. Can I ask, when the Dealbot data starts to flow into Pando, will that be open to anyone to consume? Will the data just be public?
For now, we don't have restriction to any access. Ideally, yes, as long as you have access to Pando domain, so you have access to the data. I'll say for now, I can see Dealbot just fill the bytes of a CID in the payload. So what you get from the Pando service will be a CID from Dealbot. You may need to use that CID to fetch the actual content or the metadata by some means. So this is to be clarified, and I'll sync with also Massey for further use cases. Yeah, that's it.
Awesome, thanks. Yeah, any other questions?
One quick question. Sorry if I was in and out a little bit at the very beginning of the call on the demo, but did you talk a little bit about the backend, that does the indexing and the scalability of it and so forth? Or maybe that's not relevant for this demo.
It's not covered in this demo, this topic. No,
okay,
not yet.
Okay, I'll look through your documents on it though, but it's in there if I take a look through, because I was kind of curious.
Oh, okay. No, it's not covered yet, and we haven't really tested the scalability and considered the scalability design for now.
Okay, so this is okay. This project is a little bit more looking at like the UI UX for developers and participants in the network more than what's going to happen on the back end side.
Not just the UI or user experience. We also had a lot of backend stuff. Actually, this is also we can consider a backend service, but for now it's just a centralized. We didn't put too much scalability feature to it now, so it's just like a standalone service running on a host.
Okay. All right. Thank you.
Yeah, that's a good question.
It looks good, I should say. I'm sorry, I didn't mean to. I was just asking a question, but it looks good. Thank you.
No worries. Yeah, we are also considering the scalability, considering the potential amount of the consumers and the providers. Yeah, that's a topic we are going to cover in next few days or weeks. Probably weeks, not days. Thanks.
Great, thanks. Yeah, any other questions? Cool. Well, we'll call it a day there. Thanks, guys.